picking up from where we left last day, like after the foundations, we still have the CAD. Just so today we'll be focusing on creating these columns that you see over here. So there are separate dimensions. Okay, some of them are 400 by 800, and some of them are simple rectangular squares, 800 by 800. So this information, apart from being here, is also drafted like that in the CAD itself. So if I go to query and query this block, so this is a block in CAD with the name of the column, like structural column 800 by 800. And if for this column, it's similarly marked. Okay. So the CAD drafting is done in such a way that all the columns are of a particular block. Okay. And each block has the name of the size of the column, what it should be in Revit. Okay. And it's also on a particular layer. So it is in this particular layer called structural columns. So what we'll be doing like this process is also applicable if we are doing something like, say, placing any type of point-based families like furniture, foundation, any point-based elements like doors, windows, things like that also. Okay, which can be located with a point. So this we have the first scenario, and if I go to structural columns, we have these three standard columns made. Okay, but none of which match to our corresponding column sizes. Right. So the task that is for the script is to first identify what are the different column sizes that are there in the project, and then place each one of them on the appropriate location. So if I go back and run the script once, so this, like similar to the previous one, takes the CAD itself as an input. Okay. And let me freeze. Okay, let me first run it once fully. So it has run once, and you can see that the columns are automatically created. Okay, and it takes the size as well. So if you go over here, and now I go to column, you can see it has created the required types for it. Okay. So this is what it does. It places the columns after generating the required types, like the sizes, and then taking the location from CAD, it places them at the correct position. Okay, now we will move on to the script. So the script is again divided into two parts. One is the top portion, which mainly generates the each of the different column types, like this you see over here. Okay, and the other portion is the part which generates the columns themselves. So as a starting point, for simplicity, we will just delete this entire part. Okay, so let me just save this file and run it again. So here we have this scenario. Again, we have the CAD and we have the columns, which are already pre-made in this case. Okay. So if we have such a situation where we have the correct families already made in Revit, the script becomes much simpler. Like you can see, we have only this much over here. So let me run this, close it once here. Select the CAD file and run. What happened? Okay, so this node I also have to remove. Yeah, you can see the columns are generated. Okay, I want something over here. What is this? Yeah. So the columns are placed in the correct location. Okay, so what does this script do? So we start by taking the CAD as an input and then use this CAD blocks node from this this one, Genius Loci, to import the CAD blocks in. Okay. So once we have crossed that stage, we get three outputs from it. One of them is the block name, okay, which you can see. These are all the block names list, like structural column 400 by 400, 800 by 800, whatever it is. And then we get the corresponding origin point of each of the blocks, which are all of this. Okay. So once we have this information, we simply feed into the family type by name. Okay. So what we have to ensure over here is the name of the block, whatever it is in CAD, is exactly same as the name of the family over here. Okay. So you can see whatever my block name was, what we covered at the start of the session, that whatever we are getting when we are say querying the block, like whatever this name is, str column dash rec dash 800 by 800, the name of my structural column is exactly the same. Okay. So what it does is it takes each block names and just searches for a similarly named Revit family, which is exactly what it has done over here. So once it is done, it has got each of the family positions from it. Okay. And then we can simply input all of those ins into the place family by instance point, which places a structural column because that is the family type at each of the points. The points are again coming from the block origin, which this CAD import node is giving us. Okay. And if there are any rotations, this is the last step that rotates this. If a block is mirrored or rotated, so that rotation information is also obtained from here. If we give a watch node, I think only one of the objects is not rotated. Yeah, so one is rotated by 270, so that gets detected over here. And this is just a list of repeated items because these are all levels 1, 2, 3, 4 to 14. Because each of these columns we want individually to be created. So we simply took the level which is level 1 for each one of them, and which is again the level of at which the CAD file is located, okay, which is level 1 in this case, and then just repeated it so that we have a separate input for it. Okay. Like this is simply like, and this type of technique will work for any other object as well. Like apart from columns, if you're doing it with foundation elements, which are components, families, any like generic model, the same rule applies. Like for placing families instances by point. Okay, you can query the CAD model for the data and then place it. Any queries till now? Any doubts? Yes.
Uh, Hi, sir.
Yeah.
Yesterday I asked the question about placing foundation.
Yes.
So, a rectangular footings,
Yes.
isolated footing.
Yes. Yes.
So, same method we can use for the footings also.
Yes. Yes. Like you can use the exactly same method for the footings.
Okay,
If
okay. If it is a block in the
CAD, yeah. For that,
yeah.
it has to be a block in the CAD file that you are importing it with.
Mhm.
Okay. Like if I query the foundation in my case, there I don't think there were blocks. So you can see the block
Uh,
name cannot be not applicable. They have to be turned into
okay,
blocks. Only if they are
okay.
done, then we can place it. Or else we can try placing with this also, but then it becomes difficult to how do you separate it out? Like how do you find the center point of this? Okay, for that you have to do a separate geometry operations. But as a starting point, I would suggest try with a block where your foundations are all blocks. If you have a trapezoidal footing or anything like that, like where foundation
Uh,
is a component, so I am
yeah.
assuming even when we are doing it in CAD, we would be using placing them as blocks, right? So
Yes, yes.
if you have a block,
Actually,
yeah, yes, tell me.
uh, I'm using the lookup table to create the footings. For example, all the rectangular footings
Hmm,
in CAD, I will use as a dynamic block and then
hmm.
use the lookup table to create the
Yeah,
footing.
that
So I just select the size and it is there.
yes, that also you can do. Like the same
Yeah.
point will work. So over here
Okay.
from your block name, it may go into a lookup table From there, it gets the
Yeah.
sizes, and then you just need the family name over here, right?
Okay.
So there will be two scenarios. One, your Revit model already has those families created, like we have over here,
Mm-hmm.
right? So if it's created, then the placement becomes easy. But if I run the same script and say I delete the columns, okay, and say I purge this just to remove the types
Okay.
that already exist, check none, structural column. So I remove all of these types. Okay, say I only have one type of column over here, which is standard column, which names match with
Okay.
nothing. Now, if I
Okay.
run it, this won't work because this, if I, yeah. So now this won't run because whatever block name it is feeding it in, it cannot find the corresponding families in the project. Okay, like if this
Okay.
is giving me the warning, the family
Okay.
specified name does not exist. Okay, so
Okay.
there is two ways to do it. Like when this kind of scenarios occur, one is to like previously make all the families and then run your
Mm.
script, which is a simpler option. You can see the script is so small.
Yeah.
And the other option is what I was showing you previously. Like now you can see if I go back to my previous script. Okay. So this entire portion you see over here, all it
Yeah.
does is it checks whether the family names already exist. If it doesn't exist, it creates it. So in this scenario, if you see, uh, I have none of the columns available over here. But when I run the script, let me go back. You can see the columns are generated. This is only being generated because the type generation is being taken care of this part. So like we covered the lower portion of it, right, which was pretty simple. Now if I move on to the upper part, so what this is taking is this is taking the two names of the blocks, okay, so that it can check whether those elements exist or not. And here it is again taking all the column names that already exist based upon a particular category. Okay, so this is taking the family name, and then what it's doing is it's checking for each one of the, so you can see from here to here, it is checking against this list, like list contains whether the existing any of the names matches. Okay, if it matches, then it doesn't pass it on, it's good. But if it doesn't match, then it goes over here, okay, from the out. Mhm. And then what it does is it takes whatever it gets, like at least one instance of the family should be loaded, right?
Okay.
Like if anybody has any questions, they can ask over here. Like this is a little bit complex part of the script. The lower portion was simpler, but here what it
Yeah.
does is it takes the name. Then
Yeah.
what would we have manually done? Like anything we do in Dynamo has to be possible to do it manually. So if we are doing it manually and we had this system, what we would have done, we would have taken the standard column, edit type, and
Yeah.
duplicate, right, and created it with
Mm.
the name whatever we have. So
Okay.
the script is doing the same thing over here. The script is doing exactly the same thing over here. It is taking the only item which is has is the structural concrete rectangle, and then it's duplicating that element and making the two new types. Okay. So once it
Okay.
does that, okay, it's this is just two elements setting the size of the column. Okay. The B and the H. Okay. And from where is it getting the B and the H to set? For that, it is simply using this part. This part is nothing but like taking the two strings, which is this name of the column, and then splitting things up. Okay. So the first step it is splitting with the dash into the three parts that are there.
Mm.
Mm, let me add a watch node. Once. So what is doing as the first step is you can see it has split the information that was here in the
Mm-hmm.
text, like the structural column 400 by 800. it has split it into three parts. Okay, like it's sorry, two
Okay.
parts. And here we are just transposing the list, so we can group it. So now this name has three parts. The first was structure, and then was the column, then RDC, and then the dimensions. We are only concerned with the last part of it, right?
Okay.
So here we are taking that information and we are again splitting it. So we have 400 by 400 and 800 by 800. Again, going exactly what we did in this part, doing the same thing for this. Transposing it, again splitting it into two halves, and then just converting the strings to numbers. So this part will vary for you. If you are having the block name as something different, this part will vary. Okay. This part will be the same because you will be taking whatever is not already there, duplicating the elements to create the new element types, and then setting the parameters for the newly created elements type. Like even if we duplicate from over here, right, we still have to set it. So then we have to set it whatever dimension we want. So that is exactly what this part of the node is doing.
So set
Yeah,
parameter.
yeah, it's setting the parameter
Mm.
of the type.
Okay.
These are type outputs, like these are element types, right? So it is setting the parameter like the B and the H. Like if we would have done that manually, we would have to set the B and the H of the column, right? So that
Okay.
is what it is doing over here. It is setting the B and H of that column. And once it's all over, it's using transaction N to push the data into Revit. So one more thing, if you see over here, if I undo all the scripts that I did till now, uh, let me remove this. So I have nothing, and if I'm now going back and running the main script, sorry, so I have nothing over here. Yep, Pearl Janu. Yep. So let me save this. Yep. So now if I run the script, okay, so it created the column. But if you go over here, you can see it run two times.
Yeah.
Okay. Because as of if I now undo it, you will see the columns have disappeared. Okay, but if I go over here and check the structural columns, you will see these two new types already exist. If I undo it again,
So first time it run and create the column, and
yeah,
then run to place the column.
yeah, exactly. And like this order, we are controlling it within Dynamo using the transaction end key, which is this, which tells
Mhm.
Dynamo to push whatever it has done till now into Revit. Okay, and the
Mhm.
pass through node, which waits for a particular node to complete its work before it starts. So what happens is the
Okay.
Dynamo script starts. So under normal circumstances, if you're doing something in Dynamo, Dynamo will wait for your complete scripts to be completed before it makes any modification to the Revit project. Okay. So your changes doesn't get
Okay.
passed on till the very end of your script. Okay. But here we need it to pass out the families over here so that this node can detect it. Okay, when it's running. So what we are doing is we are pushing this out and then we are running this. So if we did not have this script, okay, so if we connect this directly, and it won't work because though the types will be created over here, like this node will create the types, it won't wait for this to run. So if I go over here, go back to say column levels. So I am back to the same scenario. Let me close this script once. Yeah. Go back to column. And now if I run it, so you can see all of this is null. Okay. But if I go over here and check my columns right now, you can see these types exist. then why did it not find it? Because in this particular case, what happened is this part of the node ran immediately, even before this part of the node completed its task and pushed this out. Okay, so if it hmm, look, it created the element types, but it created after this node has run, right? So it's useless that it created it. Okay, if you go to undo also, you can see it ran. Okay, so the only way to do it is, that's why we use the pass through node over here to stop it from running, like to wait, make it wait till this completes its task, then only this will run. So if I add back the pass through node, this is a part of the clockwork package. Okay, if you, so what we'll do is we will plug it into wait for. So wait for is, it will wait for this node to complete its task before it begins. And it will be the same input, which we are directly connecting it first. Instead of that, we will connect it over here, pass through over here. Close this. Purge unused because we don't need the columns. Yeah, back to over here, and now we run it. So now you get it. The columns are again created, the types are created, and everything. So what we are doing over here is, we are just using pass through and transaction end to control the order in which our scripts are run, like the different nodes are run. Any questions so far?
It's good. We need to try. We need to
Yeah,
practice this one, so it will help a lot.
yeah, like yeah, you, like you can try modifying this script to run with a foundation. Like it should not require much modification. Like this part is the part which will require the most thing, but if you make it run after creating the family objects with the same name as the CAD, then that part will be, I think, much simpler, which is just this part. Then you don't even to worry about like pass through and things like that. These are all, just import the CAD in and then run it. Yep.
Okay.
Hi, Saurabh.
Yep. Yeah. Hi.
Can you go to graph in
Yep.
the lower part? Family dot instance mode, where you have added levels. Levels. No, no, not that. Yeah.
Yeah.
Levels. See, my problem is I'm placing my diffusers. I have multiple rooms with a different ceiling heights.
Hmm.
Okay. So I'm using same script for placing the diffusers with by using CAD with blocks.
Hmm.
I'm using same. But my problem is I'm not able to place them ceiling wise. Like few rooms are having 3 meter height, few rooms are having 2.4. So I
Hmm.
want to place directly, like you can say a ceiling based family. How I can do this?
But the thing is, you first do it in two steps. Uh, First, calculate what is the height of your ceilings in each room. Okay.
Mhm.
Then associate your diffusers with the rooms, and then you place the diffusers and give them the proper height offset, right?
But the rooms, these rooms are randomly in one room, one in one architectural room,
No, no. So
architectural.
in Wari architecture room, the ceiling height is the same, right?
No, in my case, there are different ceiling heights. I'm talking about pharma projects. So in
Hmm.
pharma, you may get different types of ceiling heights.
No, in the same
So
room. Say your room one
uh,
has
s- see, you have a plan.
different.
Uh,
Yes.
you have like 20 rooms. Five rooms are having 5 meter height.
Hmm.
10 rooms are having like 3 meter, and the rest are having 2.4. And then I have to
Huh,
place my
so that's
diffusers.
what I'm saying. Each of your room has a height defined, right? So the only thing you need
Right.
to associate is detect which diffuser is in which room.
Okay.
Okay. So then you can work upon based upon that.
Okay. So I need to find where diffuser
Huh,
first.
like
Okay.
yeah, your diffuser is in which room. If you know, then you know the height offset to give it, right? From the
Yeah.
base
Right.
level, whatever height offset you need to give, that you can give after
Mhm.
you know whatever the diffuser, like what is the height of the ceiling for that particular room is, because that information is available to you.
Yes. Right.
Yep.
Mhm. Okay.
Yep.
And
Anyone has
also,
anything else? Yeah. Tell me.
yeah, I have posted one photo in our WhatsApp group.
Regarding that least level thing.
Yes.
Uh, yeah, but share your screen. Or what you are saying, I did not understand. Uh,
Okay. 1 minute.
you will never get that index because your list does not have that 15 index available, right?
1 minute.
Like, or else I can create a range and show it to you. That's also okay. I can create it over here. Yeah. If are you sharing, or I can also share and show it to you. Wait, let
Yes.
me.
Please.
If
Yes,
you
you can.
go over here,
Mhm.
like, so if I understand it, you have a range like this. We were talking about last day also, if you remember.
Yeah.
Say this is 100, mhm, and say we can only get 15 if 15 exists in this list, right? If we
Uh,
don't have 15, we will never get it, right? Like any number we ask for.
no, no, no. Actually, that's not my question. Okay, I'm sharing my screen.
Yeah, sure.
Uh,
Yes, so zoom in. Yeah, what you want after this node, your 15 doesn't exist in this list. This 531
yeah.
list.
This list, list
Huh,
dot replace item index. I
huh.
want the outputs like uh, 0, 1, 2. Then will be A. Then
So
again
what?
4,
So this is
5s. Yes, yes, yes.
yes. So the thing is, this is a list within a list. So if you
Okay.
want 0, 1, 2, 3, 4 to be numbered one after another and not to be like this, like you can see the list. There is a first list which is your zero list on top, which
Yes.
has three items, which is 0, 1, 2, and then the third item is a list again, which is A, B, C, D, E, F, G. Then it again has items such as 4, 5. Okay.
Mm-hmm.
So one thing you can do is you can flatten the entire thing.
Okay.
Just take the list and flatten it. Just use the flatten command and you should be able to flatten the entire list. I think that's what you're trying to do. Uh,
I don't think it will work, or because these alphabets will get after value 2, and they will be.
no, so what are you trying to do? Are you trying to make a list which is like if you can whatever this list you're trying to make, okay,
Mhm.
if you can do a sample like is it 0, 1, 2, A, B, C, D, E, F, G,
Oh,
H, I, 4, 5, 6, like this list doesn't make sense, right? Or are you trying to make a list which is say uh, 1A, 1B, 1C, 1D, 1E, 1F, 1G, 2A, 2B, 2C, 2D, 4A, 4B, 4.
No, 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 not also.
Yeah,
Like, see,
so can you show me a sample of the list you're trying to do manually? Like then I
uh,
can try and tell you how you can do it in Dynamo.
okay, see, my output will be 0, 1, 2, then A, 4, 5, 6, B, 8, 9, 10, C, 13,
Just
14,
just just
15.
flatten it. You will get it.
Okay,
Just
then.
flatten the list.
Mm-hmm.
Just add a flattened node between the list and the list get item at index. So you
Okay.
want all of them to be on the same list, right? You want zero,
Yes.
1, 2, A, B, C, D, 4, 5, 6, E, F, G, H, and so on and so forth, right?
Right, right.
So just flatten it, and then you should be able to get it. Then you can just swap as you are going along. Yeah.
Okay, then. Okay.
Okay. Yeah.
Thank you.
Yeah. Thanks. Thanks. Yeah.
Can I borrow the screen?
Yeah. Sure. Sure.
Actually, I have a question here. I'm trying to do
I cannot
window.
see your screen. Can you reshare it
Yeah,
once?
yeah. I'm sharing. I'm
Yeah.
sharing. No, cancel. Share entire screen. Okay. Here I'm trying to create the schedule.
Okay.
Okay. For example, this is structural framing, and this is the beam schedule name.
Yeah.
Okay. But when I create this first column schedule, it's created. But I'll show you when I change the input.
Hmm.
Okay, like structural framing, then my schedule name is beam, but still you see the ID didn't change. It says 00 column.
So you can try one thing like closing the script and running it again. So what happens is like I have also encountered certain times in Dynamo, especially when we are working with custom nodes, they don't update when we run it. Like when we keep on running it in the same session, it doesn't update. So one solution is to run it with Dynamo Player, because every time you are running a script with Dynamo Player, okay, it is like
Mhm.
restarting Dynamo and running your script. So try that.
So like
Just yeah, like
here I restarted.
yeah,
Okay.
just
Now it's created.
so what I will do is I will
But
take those two inputs which you are changing, okay, turn them into inputs, okay,
I
and
I I tried to do
yeah,
this way also. I created two lists,
uh,
one for category, one for the name.
this should work. Like I can see a error has come, but normally this method works. Like creating list and inputting things in Dynamo, this
Yeah.
works. Just you may have to like maybe you have to duplicate the schedule type as well. If you remember the script I was
See.
just showing, I had duplicated the levels as well, right? In spite of
Yeah.
the value being the same, because sometimes when you're like inputting it into the node, if you give it three list, it correctly detects that it has to run this three times, but if one of them is just one, it may give an error. uh,
See here it's giving error. It's
yeah, can
created
you
for
see?
beam.
Yeah, so you can check what that error is. That will tell you where it is exactly facing the problem.
It's a schedule view,
I cannot read
create
it.
view.
Yeah.
Yeah, I will copy this one there in. You can read it now.
Mm, value cannot be null. So just check
Uh,
one of the values it is considering as null. Why it is so? That we have to check.
okay,
Okay. Like you can share, if possible, share the script, and then it's easier to debug.
sure,
And
sure.
yeah,
I
or you
will.
can just
I
post
will.
it in the Dynamo forum as well. Yeah,
Okay, okay. Actually, here what I did, I have these parameters.
yeah,
This is everywhere. So in
yeah,
each model, I have to create these schedules.
yeah.
for the
Got it.
beam,
Yeah. Yeah.
for column. So every time I'm going and getting all the fields manually, so I'm trying to do with the script. So instead of
Okay.
doing manually, so if I run one time, so it will
Yeah,
I will
that
have
should
all
work.
this.
I
Yeah.
just have one thing. We can copy schedules, right, between projects. Won't that be simpler?
Yes. Yes, it is simpler, but uh,
Okay, I get it.
many other.
Yeah.
Yeah, I'm trying to do something.
Yeah, yeah, yeah. Sure. Yeah, just if possible, share the script.
Yeah,
It
sure.
will
I will
be
share.
easier to take a look and come back to you. Yeah.
I'll
Yeah.
share. I'll
Yeah.
share. Thank you. Thank you.
Thanks. Thanks. Yep. Yep. So that's it for today. If anyone has any questions, we will take them, or else we will end the session at that for today. Sagar, I think we can close for today. Yeah.
Thank you.
Okay,
Thank you
Yeah.
yes,
very
sir.
Thanks.
much.
Thanks.
Thank you.
Thanks.
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 Thank you.
Thanks for the
Thank you.
session, sir. Yeah.
Thanks. Thanks.
Thank you. Thank you.
Thank you, sir.